In the previous couple of videos, we've been talking about loops. Specifically, we talked about the while loop, we talked about the for loop, and kind of how those work. Now, the thing about them is those loops pretty much ran until completion, especially the for loop. The for loop, we put in a count control, and it would go through the whole count until we found that the loop terminated on its own, meaning it did a certain number of commands or a certain sequence of events occurred in their entirety. And that's kind of how we dealt with loops. Now, there may be a situation that comes up where you say, you know what, I want this loop to happen, but it might be necessary to terminate the loop earlier. Meaning it might be that it's unnecessary to continue the loop as a whole. You need to refrain from further executing the procedures inside that loop. Something just may come up, or it may appear that you need to start the next turn of the loop without completing the current execution of the loop. So there are some situations that come up. Now, the nice thing about Python is it does provide two instructions that let me go through and one, either stop the loop in its current cycle or make it move on to its next cycle. Those are break and continue respectively. So let's take a look at an example of how we might do something with break. So I'm going to open up a file here. I'm going to go to new file, and we're going to start ourselves with a pretty simple little program. Okay, we're going to set up a max number. So I'm going to say max number is going to be equal to negative 1, 2, 3, 4, 5, 6, 7 nines here, 8 nines. Actually be better, right? We're going to create ourselves a counter. The counter is going to be equal to 0. So I'm just establishing a couple variables here. And what we're going to do is we're going to say while true. Now, we've talked previously about doing something here with while true. True is always true, which means this loop is going to go on forever unless we give ourselves a way out. Well, we're going to do that. So we're going to say number is going to be equal to some integer. We're going to ask for input from the user. So enter a value. Okay, I don't know what that value is going to be. We'll let somebody enter that. Okay, and we're going to say if number is equal to a negative 1. We're going to break. Okay, what that is going to tell the program is that if the number is equal to this, it's going to terminate the loop. Okay. Otherwise, we're going to do counter plus equal 1, and then if number is greater than max number, we're going to say that max number is equal to number. And then we want to go out if our counter, we're going to print the largest number entered is whatever our max number is. Okay. Else, we're just going to print you have not entered any numbers. Okay. So the purpose of this program is just to look at how we can be stuck in a loop forever and ever and ever until we give ourselves some kind of way out. Now, normally, we'd have some kind of other condition here, like while keep going is equal to y, or while continue equals yes, right? We'd have something like that. But in here, we're just doing while true. And what's going to happen is they're going to keep being prompted to enter a value so long as they don't enter a negative 1. If they enter a negative 1, this break is going to kick in, the loop will terminate, which means it will automatically kick down to this if. So it won't do this, it won't do any of these things. The loop immediately gets terminated and it kicks out to here. Okay, so let's see how this works. I'm going to save this. I'll put this in my Python folder here. And I'm going to call it break test while. Okay. So enter a value, 200, 20, 10, 50, 333, right? As you can see, it keeps going on and on and on and on and on until finally I enter a -1 and then the loop terminates. Okay? Now, I know what you're thinking, or what you're saying is like, well, why didn't I just do this? You know, while some variable. So I'll put in while loop ender, I don't know, is not equal to -1, right? You could do this, right? I mean, I don't know, loop ender is just something I made up. And what would happen is it would keep going so long as that's not equal to a -1. And that's fine. You could have done that. This is just another way in which we can do something similar without having to introduce an extra variable. Okay, it kind of helps out in that regard. If you don't have the code typed in, go ahead and pause the video right now and type that in. All right. So all we're doing here is just trying to find whatever the maximum number is. But the purpose of this break is to terminate the loop when we need to. Now, let me show you another example. Okay? Here's another sample program that utilizes break. All right? So what this is going to do is we're going to use a for loop in this time. Okay? So we're going to iterate through a range of numbers from 0 to 100, and we're going to keep doing that. Now, if I, for whatever reason, equals 15, it's going to terminate the loop and just print game over. Otherwise, it's going to print whatever the current number is. So what this program should do is it should print 0 through 14. Once it gets to 15, the program's going to stop. It's going to say game over. Okay? Go ahead and pause the video and take a minute here to type this in. All right, so let's see how this works. So if I run this, oops, forgot my parentheses around print. Sorry. I originally wrote this on an older version of Python, Python 2.7, and Python 2.7 didn't require the parentheses. Python 3.7, however, does. So just add those parentheses around those print statements. Okay, so let's rerun this. And there you go. So as you can see, what happens, okay, is we're going to go through 0 through 100, but the idea here is if f is equal to 15, it's going to break. And again, break means immediately terminate that loop. So it terminates this loop, this for loop. Since that ends, it goes this print statement and prints game over. Now, let me show you a little more complex example. Prime number generator. Okay, prime number generator. In this case, what we do is we're going to use a couple for loops, and we're going to put a break statement in here that's going to allow us to kick out of this. Now, we have a nested for loop here. So what's happening is we're going to say, all right, some numbered sequence from range 2 to 100. All right, so I'm going to change this to 101 because I want to include 100 if I can. So this is just going to iterate through 2 through 101. All right. Then we're going to come in and say 4x in range of 2 to whatever number that is. So the first time, I'm going to show you, it will look like this, range 2 to technically 1. Well, it'll say 2 to 2, right? That's what happened the first time when this comes in. The second time, it'll say range to 3. Third time, it'll say range to 4. Follow me? It's going to change this number to whatever this number is up here. Okay? Then what it's going to do is it's going to take the number, whatever that is, modulus of x, and see if that is equal to 0. So the first time it comes through, number is going to be 2, and x is going to be 2, right? So the first time in, number is going to be equal to 2, and x is going to be equal to 2. So basically what that's going to do is then say, okay, 2 modulus 2, if it is equal to 0, meaning there's a remainder, then it's going to print number equal to whatever. Okay, it's going to print a statement out. If that's true, and then it'll print, and then it'll immediately break. Now, here's the catch. Because this break is inside this for, it will only terminate this for loop and then return control to this outer for loop. Because break will only terminate the innermost loop that it's a part of. So since this break is inside this for, it terminates this. Now why do we use it in this scenario? Well, if I go through and let's say we get to a point where 2 for our ranges, let's say we get to a point where we have 2 to 8, for example. Okay? So if number is 8 and x is 2, well, we know that 8 is evenly divisible by 2. That makes this statement as true, which means that 8 is not a prime number. Okay? And since 8's not a prime number, we want to make sure that we tell it it's not prime. But do we need to do any more testing is the key. Meaning, do I need to make sure that 8 modulus 3, or 8 modulus 4, or 8 modulus 5, or 8 modulus 6, or 8 modulus 7? Do I really need to test all those? If I have already determined that the first time this goes through where 8 and 2 are used, once I've already disqualified it as a prime number, there's no sense in going through the loop again. That's why we use the break. Because that allows me to say, you know what, I've done my testing, I need to get out of here, right? I have got to a point where I no longer need to keep looping, let's skip on to the next one. Okay? So what that does is, okay, fine, break this loop here and continue out the other way. Okay? So let's look at how this works. So if I run this module, you can see it goes through, and this is exactly what it's going to do, right? It's testing all those prime numbers, and what you're going to find is that the first number that disqualifies it from being a prime number is what you'll see. So like 90, first it found the 2, because 90 is, excuse me, 90 is evenly divisible by 2. But then 91, it had to go up to 7. And then 93 had to go to 3, 95 it had to equal 5. Rather than testing every single number, once I found a disqualifier, then I want to stop. And remember, a prime number is a number divisible by only 1 in itself. So that's why we have here, we test it. Once we find a disqualifier, we break and move on. So when it gets to 8, and it finds out that 8 and 2, it's then going to say, okay, fine, I'm done. X is not going to increment this time. It's going to immediately go to 9. Then X is going to be 2 again. So then this would change to 9, right? So then they say, okay, 9 modulus 2. Okay, well, that's false. Okay, go back to the if again. The key here is notice where this else is at. This else is with the for. It is not with that if. Which means if this statement's false, it goes on to the next iteration. The only time this else runs is when this for is completed. And that for gets completed by one of two ways. Either it gets to the end of the range, or it hits this break. So 9 and 2, well, that's false, right? Because 9 divided by 2 is 4 with a remainder of 1. So it goes back through and goes then to 3. Well, 9 modulus 3 does yield a 0, so that means this is now true, so it prints this statement. So if you see the output for 9, we go back up here, and a little bit farther. There you can see 9 is equal to 3 times 3. So another example. So then let's say the next time around we get to 10, right? Well, the first time the number is 10 and x is 2. So 10 modulus 2 is a remainder of 0, hence we go through, okay? So that's the idea here, all right? So break does give us that ability. But remember, break terminates the innermost loop, okay? It immediately terminates that loop. In this case, it terminates this loop because it's a part of it and returns control up here. If it's just one loop, as we looked at in one of the other ones, right, then it is simply going to terminate the loop it's in. It gives me a way to prematurely end the loop. Well, I shouldn't say that. It terminates it because it understands there's no need to continue. Now, this is different than continue, okay? Continue behaves as if it automatically reached the end of the loop, okay? So rather than saying we're just going to terminate the loop, it's going to allow me to continue on to the next cycle of the loop, okay? So here's an example. So for I in range, I'll give you guys a chance to type this in, don't worry. I have this outer loop. I'm going to print what the current value of I is. Then we're going to go and count down from 10 to 0. Now, here's the thing. If x is equal to 5, we're going to continue and then print x. So take a minute here, go ahead and type this up, and then we'll talk about how it works. All right, so let's go ahead and run this. So I'm going to run, and I want you to see what happens here. Parentheses again, right? Good old Python 3.7 versus Python 2.7. Put my parentheses in here. Oops. Parentheses there. And my parentheses here. All right, so I'm going to run this. Save it. Now watch what happens. All right. What I want you to see is that the current value for I was 1. And let me clear that out. Let me get rid of some of this stuff. Let me get rid of this, okay? Just because I know it's confusing. So I don't want to see that in there. So I'm going to run this again. All right. So what I want you to notice here is when it counted down, it went through this loop a couple times because of the range I had going. But notice what happens. 9876, 43210. 9876, 43210. Notice there's no 5, okay? That's because once we hit 5, it says, okay, go to the next iteration. No, so continue goes back to here and continues the next iteration of the loop. This is in contrast to break, okay? So I'm going to show you the difference here. So I'm going to uncomment this. And basically this is going to let me run the loop twice, is what I'm doing. And I'm going to uncomment break and comment continue because I want you to see how the two are different. All right? So if I run this now with the break instead of the continue, notice the loop stops, right? It went 9876 and stopped, and it took and removed it from this 4 to this 4. That's different than if I use continue. Okay? Continue, as we'll go through and look here, notice the first time it goes through, you got 9876, 43210. 9876, 43210. Okay? So the biggest difference between break and continue. Continue says, okay, we have reached some kind of situation here, right? We want to deal with our loop, so we don't want to terminate the loop. We want to go just to the next iteration because we have reached a condition that we feel it is necessary to say, okay, you know what? Skip this iteration of the loop and go to the next one. So that's what this is doing. Continue says, okay, x is 5, continue, that means go back here and go on to the next one. So that's why you see it go 9876, 4321. Break is different. Break says immediately terminate the loop. So if break was in, this once x would get to 5, break would say terminate this loop and go back up here. That's why you see it say 9876 and then nothing else like that. Okay? So break and continue are extremely powerful statements, and you have to be very cautious of how you use them, because if you don't use them correctly, you may get some very interesting results. Okay? Here's another example using a while statement. Okay? Again, feel free to pause the video and type that in and test it out. Do go through the difference between continue and break and really see how they work. In this case, we're decrementing by 1 just to see how it would work. And then here's another one. Okay, this is another situation where we're using the range command to decrement, and just again play with the difference between continue and break and see exactly what's happening. Now, make sure when you do these, okay, you make sure you put the parentheses around your print statements so that it works. Okay? So there's one you can try. Here's another one. Again, make sure you put your parentheses around your print statements. Okay? But like I said, feel free to pause the video and play around with these pieces of code and really watch to see how continue works versus break works, because both of them have their place. Both of them do very, very interesting things. They just don't do the exact same thing. You will see these quite a bit, so be sure that you know the difference between the two. Okay? All right, so there's that one, and then there's one more. Again, you can pause the video and check this out. And then here is the one for the prime numbers. All right. Okay, well, as always, if you have questions, feel free to contact me. If not, I bid you good morning, good afternoon, or good evening.